Good afternoon. My name is Antonio Furukawa. I'm an architect at Sasaki Associates. I will be explaining you a little bit about the building that we just finished with the University of Lima. It's going to be more about our design process and how we use BIM as part of documenting, coordinating, and making sure that we have the right documents for implementation. Just a little bit about Sasaki. We are a multidisciplinary firm. We have more than 300 people working. This picture was taken before COVID and in our incubator space. Since then, we have moved to Boston downtown, but we have all these different disciplines working together. We have architects, planners, urban designers, landscapers, and everything that you see over here. Whenever we have the chance, we try to work together, all the different disciplines in just one single project. We are a global practice. We work all over the world, and we have offices in Denver. Our headquarters are in Boston, but we also have an office in New York and in Shanghai. And we're about to open, I think, a new office in LA pretty soon. We basically work with universities. This is a list of partial list of our clients, and around 70% or 65% of our work is related, campus-related work. We usually work, do everything from planning, for implementation of even learning environments, classrooms, student life, housing, sports, and landscape and open spaces. And we have been recognized, thankfully, for a lot of our design work. We have some of the awards that we have recently won, recognizing our design skills. And we were talking a little bit about the University of Lima's CIT, the Center of Innovation and Technology. A little bit about history, as Alex was saying. It all started with the master plan that Sasaki did way back in 2018, with the goals that we had defined with the client of optimizing land use. And then as part of these high-performance buildings, the goal in 20 years of implementation is to also reduce the energy consumption for this size of campus in 25%. The master plan, when all the new land is acquired, basically tries to create like a center open space with all different quads that could be easily be implemented over time. One of these quads, the first one to be implemented, was this student hub, which had the rec center. There's a little project that also Alex showed with a renovation of dining hall. And then we have the engineering building, the one that is highlighted in light blue, and the library. When we did the master plan, we did it so that it was easy to implement and very flexible. And point in case, when the COVID came, we had the opportunity, because the engineering building was supposed to be the fourth implementation on the master plan, but we had the golden opportunity to have the campus closed for a whole year. So they decided just to demo an existing building, and the fourth building became the second one being implemented. This is a little bit massing study of how this building could look based on parcel capacity. So this is at the master plan level. And this is the results. This picture was taken a month and a half ago. This is the overall result of the two first buildings to be implemented on campus. So a little bit of, what's the concept behind the building, one of the constraints that we had, and a little bit of data. The building is 10,200 square meters. It's developed in 5 stories, 1 basement and 1 terrace. It's going to be LEED certified. And one of the most important things that the building needed to have was program visibility. It was very important for the buildings and for the new buildings to be implemented so that people could see what was happening. Not only from the kids studying, but we wanted to showcase what the university was doing in terms of innovation. Also, because we don't know what's going to happen, program flexibility and adaptability over time was super crucial in the concept of the building. And then for us, pedestrian circulation is the most important thing so that we can have connections of the different programs in a way that we can promote the different programs and the different disciplines. Some of the challenges that we had had related to the existing buildings, and we'll see that a little bit in part of the show, and the proximity to existing structures. So this diagram shows some of the constraints. We had, buildings very close to a building. So that's why we developed this idea of folding the plates so that we could create terraces on the massing of the building. Just to show a couple of buildings, a couple of floor plans that show how we could adapt, the different phases that we had. This is on the 5th floor. At the very beginning, we would have only classrooms. But the idea is that we will have these different laboratories in the future. So the whole building has been designed so that it could be easily be implemented for the labs. This is a food lab that's going to come in the future. And everything has been modeled in BIM. And all the consultants' work has been modeled in BIM, so we could easily see where all the conflicts were. We could easily go back and forth for coordination for phase 1 and phase 2. A quick, concept section of the building, how we have all the different labs or labs that will turn, classroom that will be turned into labs, with the idea of having, the pedestrian circulation, tying all these collaboration spaces with the idea of integrating the visitors so that they could see what's happening inside the building. Visibility from the outside in and inside out was very important. And then we developed strategies for sun mitigation. We used the model, the BIM model, to do simulations so that we could mitigate the amount of radiation. We could do with modeling for natural ventilation. So some of the metrics that we were able to do based on those simulations was to reduce the amount of radiation into the building by 35%. And we optimized the sizes of the windows and openings so that we can have natural ventilation through all the spaces in the building. This is a section of the building taken from the BIM model. Just so we use all these different diagrams to show the client how the program was being organized. On the right, you'll see the existing building, the one that has those constraints about height. And on the left is the new addition or the new building that integrated, through an atrium in the middle with natural daylight, the whole circulation of the building. These are hard to read, but this is how the program has been organized in different floors. And then the circulation that happens through all the spaces and the all these, what we call the social armature, all these public spaces that were to happen in different places throughout, the whole vertical circulation of the proposal. Just wanted to show this one because this is how we have the model at the schematic design level. We use this one for coordination with the consultant's work. You'll see a little bit here, there's some stuff that there's inconsistency in the models with existing conditions. We use that to show the stuff that needs to be demoed. We started to integrate the consultant's work into the model. We do try to do, we try to be very, what we call model efficacy, have to be very, the fidelity of the model needs to represent exactly what we're trying to achieve or study. So this is the model at the end of the schematic design. Just a couple of pictures of how the space looks, as built. Similarly, this rendering was taken from the model when we had it done at the DD level. We had all the consultants' work integrated in the model. We showed this rendering to the client as how the building was going to look like. And this is, the picture of the building as built. So model fidelity was very important, so we could test, all the design intent that we wanted with the work of all the consultants' work integrated within the model. Now I'm going to be showing just pictures of how the building looks, public spaces for, as part of the pedestrian circulation. This is the atrium space, on the right is the new building, on the left the existing building that we did a green wall. But, a lot of the circulation of the building is thought out not only as, as a transition, but a place to be at. We want to promote the kids to have, a place to study or hang out between classes. Visibility of program, transparency was very important, so that you could see, what all the different peers are doing, but also have views to the outside. All these, this part of this social armature, we had another amphitheater on the 4th floor overlooking down the plaza. And then we have this amphitheater where this will be overlooking down. Beneath that is a coffee shop. Coffee is very important for as an attractor for program. Out on the terrace, we have part of the recommendations for the master plan is that now the university doesn't have unusable terraces. We always have now all the mechanical, some of the mechanical equipment, but we also use the terrace for trailers with PVs, and where we have, the kids also hang out and have the nicer views towards campus and towards the city. And this is just, the last slide, the how the building looks. This is from a couple months ago, and with very transparency at the bottom. We want to be, be able to the experience of very, very open at the very bottom, and then on the top, we have this the folding of the slab so that we could protect the building from solar radiation, but we got a screen also that gives us a lot of visibility, during day and night. And I think this is it. Thank you.